Okay. Today we're going to go back a little bit, and I'm going to spend a couple of days on this assignment because there's some tricky parts, and I want to make sure you guys get everything. All right. So today we're going to be solving absolute value equations. And let's see if you guys remember, do we know what an absolute value is? What's the definition of absolute value? Okay, maybe we didn't talk about this. Absolute value is a distance. And it's a distance from 0 on a number line. And that's the definition of absolute value. It's a distance. Okay? So if I'm standing here in the middle of the room and I point to my left, maybe the distance from where I'm standing to the wall on my left may be 15 feet. Well, what is the distance from me to the wall on my right if I'm standing in the middle? It's also 15. It's not a negative 15, is it? Okay, it's 15 feet both ways. Go ahead. So if I say we know what absolute value looks like, the absolute value of something is equal to 15. Yes?
So if it's like the x could be a negative?
Yes.
And then, but if it has the two lines, it would be positive.
Anything that we take out of absolute value, right, is going to be a positive. Because x could equal, and let's say in case 1, because there's always two cases if you have a variable inside absolute value. In the first case, whatever's inside this absolute value could equal 15. In the second case, whatever's inside could equal negative 15.
Will it always be negative if the absolute value?
The case, in case 1, what's inside could equal this number. What's inside could also equal this number. For instance, if I take the absolute value of 15, doesn't that equal 15? Okay. Could x equal to negative 15? What's the absolute value of negative 15? 15. Okay? Very rarely do I say always. Okay? I don't want to say always.
So if it's a positive, it's going to equal the positive, and then if it's a negative, it's going to equal the positive.
Yes, that is true. Austin, you had a question?
Yeah, how do we know which one? How do we know which number it is?
It's both numbers.
Always?
Yes. Well, when you have a variable inside, most times you're going to have two answers. Okay? Now the answers for here, if I ask you to solve this equation for me, if I ask you to solve that, you're going to tell me that x equals 15 or negative 15. And those are your two answers. Okay? So that one was fairly simple. Let's try another one. The absolute value of x plus 3 is equal to 10. Now, I'm going to do every single problem, and this is what I want you to do on your homework. I'm going to do every single problem the way I did the first problem. In case 1, write out case 1. What's inside the absolute value could equal 10. In case 2, what's inside the absolute value could equal what? negative 10. And then we want to solve both those equations for x. So we can solve it easy enough. I'll just subtract 3 from each side. X could equal 7. That's one answer. Ozzy, if I subtract 3 from each side here, what do I get? X equals what? Not negative 7. No. Negative 13. Negative 10 minus 3 is negative 13. And let's plug it in and see if it works. Look inside the equation here, the absolute value, 7 plus 3. Yeah, that's 10, and the absolute value does equal 10. If I plug in negative 13 plus 3 is what? Negative 10. And the absolute value of negative 10 is 10. So the two answers here, x could equal 7, or x could equal negative 13. So the two answers are not always the same. Carly, did you have a question?
Oh no, so that's what that symbol was on the board, which is or. I couldn't.
Or, yeah, I know. My writing is not the greatest. But that word is or, yeah. Okay? You want to do another one? Let's take the absolute value of 2x minus 3 is equal to, do you think, Eric, do you think I could put equal a negative number? Why not?
An absolute value is always positive.
Yes. So if you see where the absolute value of something equals maybe negative 5, what are you going to write? No solution. No solution. No, you cannot. No. If that's the original problem, you write no solution because the absolute value, like Eric said, is always positive. All right? So what I want you guys to do, let's put another number in there, and let's put a positive number in there. And let's put 11. Okay? And I'd like you guys, I'm going to give you a couple of minutes, and I'm going to let you solve that problem the way I did the other ones. Case 1 and case 2, and see what you come up with. And then I'm going to ask for a volunteer to come up and do this problem on the board, on the smart board. Let's see. I'm just going to look around and see who would I possibly ask to do this problem on the board. Somebody who has a Z in their name. Zach?
Yeah, I think it should be that.
All right, I'm going to give Zach a little bit of time. Oh, it could be Ozzy, yeah. But it's not going to be. I think it's going to be Zach. I'm going to give Zach a couple of seconds here to work out these problems. It's not easy, by the way, coming up to the board, and so we don't want to laugh as you jump on the board. I've had a lot of practice writing on the board, but if you don't have a lot of practice, it's not as easy as it looks. Did you come up with the two answers, Zach? Okay, come on up. Are you okay coming up and doing it? All right. Go ahead. Case 1. And this is what every one of you guys should do. Believe me, this stuff gets harder. But if you have a nice system that you can use, it's going to make your work a lot easier. Go ahead, Zach, just because I'm talking. All right. both sides. And divide by 2. X equals 7. That is correct. That's one answer. In case 2, what's inside could equal the opposite. Very good. Dividing by 2, x equals -4. Perfect. Thank you, Zach. That was Zach Mesner, ladies and gentlemen. All right. Case 1, case 2 for every problem, okay? For your homework tonight, and remember what I told you guys, we're going to spend a couple of days on this. And I'm going to give you one more example. I'm going to have to give you one more example because I see some problems like this. We cannot, it's a little bit different, but we cannot go to case 1 and case 2 just yet. So what we have to do in this case, we want the absolute value all by itself. So what I'm going to do is add 2 to both sides of the equal sign.
Could you add 4 or no?
No, you cannot add 4. So now we have 4 times the absolute value of 2k plus 3. The 2's cancel, and 6 plus 2 is 8. We cannot distribute that 4. We can't do that. We don't have that property. So what we have to do now is we have to divide by 4, both sides. Okay? So now I've got the absolute value of 2k plus 3 equals 2. And now I can go to case 1 and case 2. Yes, sir?
So if the number's on the left side, you have to divide it, and if the number's on the right, you just subtract it.
Well, this is a multiplying here. And so to get rid of a multiplying, the 4, we have to divide. And with the -2, that's a -2. So then I have to add 2. Okay? But what you want to do is get the absolute value by itself first, and then you can go to case 1 and case 2. And I think we've done enough examples. All right, so there'll be a couple of problems that you have to do like that. So I want you to do on page 393, and I want you to do problems 3 through 23, and I'm going to give you, we have about 9 minutes left. I'm going to give you just the odd problems today, and then we'll continue with this section tomorrow, so 3 through 23 odd.